Okay, so now that we've kind of covered some of the most basic elements that define what a control element is, we really examined hyperlink, which is like the simplest form of a control because it can have an action event and just a piece of text that you can bind an action event to. Then we looked at label, which is like a passive control, something that displays data but doesn't really interact with the user in any way. And then we looked at what I think is the most fundamental of controls in a GUI-based system, which is a button, which has lots of options to contain things. So it's more than a hyperlink, right? Where it feels like it's a parent in itself, but also kind of feels like a its own kind of leaf node, something that you interact with. And you bind a action listener to it. So after examining that, let's take a look at all the control elements that are available to us inside of the controls package for JavaFX, just so you can see all the different mechanisms that you can pull data, that you can pull input from your user. And so this will be just a quick overview, a crash course where we'll just burn through what is available for us with some example code and reference code for you in the future. So as you start building out your own GUI interfaces, you'll be able to use the slide deck as a resource. So really the goal here is just to make you aware of what all your options are in terms of defining your control forms, your forms for defining your controls. Okay. So this is going to be quite a massive slide deck. We'll have an introduction into control. So we've looked at subclasses of control already, but we'll finally take a deeper examination into the control class. And then we're going to look at all these subclasses very rapidly. Now, the subclasses we're going to look at in this particular lecture are really going to just constrain themselves to what we're going to call exterior nodes, or what are typically thought of exterior nodes. So even if they are apparent to another node, they feel like end artifacts inside of our interface. There are another set of control classes that are worth looking at, which are called control containers, which are really designed to contain other elements, and they're interior nodes that feel very much like container classes. So these feel very much like element classes where they could be apparent, but they still feel like they are a leaf in and of themselves. They are something to directly interact with. Excuse me. Okay, so a quick introduction here is, well, the package that all of our control elements or components are going to be defined in is going to be inside of the control package. So the JavaFX user interface controls are specialized nodes in the JavaFX scene graph, especially suited for reuse in many different application contexts. They're designed to be highly customizable visually by both designers and developers. So since controls are nodes in the scene graph, they may be freely mixed with any other type of node like groups or images or media or text, and that gives you, or even basic geometry shapes. So it gives you a lot of control in designing your interfaces. And so while they might not be trivial, it is easy to style them, using CSS or any of the other mechanisms that we have to be able to adjust your layout and the style of your controllers. So in terms of the way that JavaFX architecture works for the control class, controls work for follow the classic MVC design pattern. So actually the control is the model inside of the internal mechanism of JavaFX's event handling system. And the reason why is that the control is the thing that can have state in and of itself. And so the control class itself doesn't know how it's rendered or what the user interaction is. So these tasks are delegated to the skin, the view, and then you can affect that with the style. which may then internally separate the view and the controller functionality in separate classes. So this isn't, so this is all internally handled, but I just want to illustrate to you that even our controls class is using an MVC pattern to separate its responsibilities from what the control looks like versus how the input is captured into it versus the state that it maintains. It separated those three responsibilities. So just highlighting that this idea of MVC permeates all throughout the Java code base. It's a very common approach of breaking your code down once we start designing things that are designed to have views and have sets of outputs, sets of inputs, and a internal kind of encapsulated state-driven system in and of itself. Okay, so the control class itself extends from parent. That's why any control can technically be a parent. So it's not technically a leaf node, although sometimes it's useful to think of some instances of controls to be leaf-like. But from the perspective of a developer designer, the control can be thought of as if it were a leaf node in many cases. And in particular, the control classes we're going to look at in this presentation are going to be those. We're going to not look at the ones that are designed to be more or less the container style or the interior type of node. So for example, you might consider a button as if it were a leaf node, a simple leaf node. Okay. So here, if we want to actually look at the control class declaration, we would have the control itself is an abstract class, right? That extends the parent, which itself extends node, and that allows any one of these to be inside of our node graph, our scene graph. And it's going to implement Skinnable. Skinnable is the interface that allows us to define the view on that. So really, though, for any specific set of rules that we care about in terms of the control class, we need to look at the subclasses. We have looked very extensively at some of the subclasses. We've looked at button, we've looked at label, and we've looked at hyperlink. Now let's look at the other subclasses that are leaf-like, that are like elements that we would directly interact with. Oh, and then we have also the idea for styling controls. Well, we can use CSS to style. We've already seen examples of this, so I don't want to spend too much time. So some of the stuff that we've kind of covered topically, just talking about controls, I don't want to spend too much lecture time discussing. Yep, all of our UI controls can be styled using CSS styling. Okay, so here, this is the next part that I think is worth mentioning. We can pretty much separate the subclasses of control into two different categories, those that we think of as external nodes and those that we want to treat as internal nodes. So external nodes are like the leaves in our GUI tree, whereas internal nodes are like the layout components or like things that can contain other nodes. So we're just going to focus on the external nodes, or what I'll call control elements versus control containers in this section. Okay, so with that said, understand there are actually more classes, subclasses of control than what we'll cover here. And I'll give a supplemental slide deck that just has that information so you have reference to it. Okay, so the first that I want to kind of just give you a preview of is the menu button. So the menu button control works like a regular JavaFX button, except it provides a list of options which the user can choose to click. So each of these options functions like a separate button, meaning your application can listen for clicks and respond individually to each option. So let's take a look at this. So an example here is I might define a set of menu items. So I'd have these menu items, let's say is option 1, option 2, and option 3. Each one of these then will be nodes that I can then embed into my menu button, and I can set up event listeners for each one of these actions. So this is like let's take a look at how this would be rendered. So here, when I create a new menu button, I'm going to give it itself like some kind of heading element, options, and the individual options could be like option 1, option 2, option 3, or whatever I want to put there. And then this here is the node that I might want to use if I also want to have an image or some kind of icon alongside my menu button. And then I can have any number of menu items, a variable length of arguments that I then pass into the constructor here. So if I leave this null, what we're going to see here would be something that appears like this, right? Where I have my options, and then it's going to show me what my options are. So when I click on this, it'll show me my options, and I'll be able to scroll through this, select one of those, and then it'll call the event listener that is tethered to that option that you selected. So again, if we actually want to see what the code looked like, the actual code that would actually run for this, I would import my menu item from control package. I would import my menu button. I need menu items to add into a menu button, right? So that's one way that a menu button distinguishes it from a classical button. So here I would set up all my individual menu items, and then I could create a new menu button and give it the labeling so that when you click on it, it will then highlight these things here, these menu items. And again, just like with button or any other control, we can affect a lot of different characteristics that actually are part of the style. We can affect the font if we wanted to with the set font method. If we wanted to apply an icon into our menu button, we can do that. That would look like this. Let's take a look at some of the source code. So suppose I wanted to do an icon, and icon's effectively an image. So everything I would need to import for an image, I'd need to import. So that's going to be my file input stream. It's going to be my image class. It's going to be my image view class. And then I'd actually want to build out my menu button. So I'm going to need menu items for that. And then finally the menu button. So these are all the classes I would need if I want to create a menu button that also had a icon in there. So then I would create all my menu items. I would create my menu button here. Oops, did not want to do that. I create my menu button here. I could leave this blank. If I leave that parameter blank, then I could set up so I can set up a file input stream around the actual PNG of my icon. Then I wrap an image object around the file input stream to go ahead and model my image inside my Java code. Then I can pass my image, a reference to that image, to the image view, wrap that around and attach it. So now I have the image view. And then if I go ahead and on my menu button, use the set graphic method and pass it an image view element, then that will display in alongside my menu button. So here we could see that image here, and then that's the text. And then that's my set of options. So just two different ways to do the same thing. You could do it just as text, or you can add graphics into there. Now, the important thing about a menu button is, well, how do we respond to menu item selections? So let's take a quick look at the source code there. So suppose that we have a menu item here, right? So this menu item we have a reference to. So each of these menu items are eligible to be the subject of a event handler. So each one of these menu items has a method set on action. So for any one of these, we could define a unique callback function, a unique event handler, by setting it inside of that method. So again, the old way we could do this is to create a new event handler. And then we can even use the parameter typing for that. So a new event handler of data type action event. And then we will then implement, since that is an abstract class, we'll go ahead and implement it, and we'll implement the abstract method, which is the handle method, where it takes in a action event and it will define our logic. Again, the more modern way of doing this using the Lambda expressions would be, we take an event and then use the arrow operator and then bind that to a code block that will allow us to use the event object or instance inside this code block. And then we can put whatever code we want inside of here on our menu item 3. So again, two ways to do the same thing. The second way is the preferred way in modern Java, but either is valid. Okay, let's look at another type. Let's look at the split menu button. The split menu button looks very similar to the menu button, but effectively it splits the option from the button part, hence the term split menu button. So here you can select one of these choices, and in the menu button, it would instantly go ahead and apply the event listener on the menu item itself. Here, it's going to bind it on when you click there. So you can click here, grab something, and then that will go ahead and allow you to use the button. So a quick way of how we can go ahead and instantiate that, you just call the constructor split menu button. We can set text in there. We can set the font, pretty common for all these control options right here. So just like the menu button, we would register menu items into a split menu button. And so here is one way. So if you have a button, you can get the items, and then you could actually add all and then add all. We haven't seen that yet. So let's take a look at how we might be able to respond to menu item selections. Let's say we have these 3 different menu item instances that we've created. Then on each one of these, we could set an on action. So we can set inside the on action method some Lambda expression, some callback function, an event handler that's going to do a distinct behavior. Oh, I don't like that. No, that's fine. Let's change that to, okay. Okay, let's take a look at the toggle button. So JavaFX toggle button is a button that can be selected or not selected. So like a button that stays in when you press it, and when you press it the next time, it comes out again. So it has the ability to toggle on or off effectively. And again, I want you to think back of like filling out web forms. A lot of these inputs you probably have exposure to, either filling out forms on the internet, or using like game GUIs, or using mobile apps, right? Like these are all very common metaphors, but they're distinctively slightly different in their behaviors. So that's why we're trying to run through them relatively quickly. So a toggle button just has a class called ToggleButton, same parameters as a normal button, right? Where you pass in a string to display as one of the options. So if we were to actually look at the source code, we can import ToggleButton from the control package. And then while we're setting up our GUI application, if we want to create a toggle button, we can just create an instance and then add it into our layout component. Again, all these are technically also parent classes, so you don't have to put them in a layout component, but you should. Everything should go in a layout component. And so just a quick concept of what this looks like. So if we were to then like display this code, this is what our toggle button would look like here. And at default, it's not going to be pressed. And this might be hard to see here, but when I press it, it gets darker, right? So it illustrates, hey, this is currently pressed. And so you can set the text, you can set the font, you can read the selected state. So here you can check to see if that toggle button is currently set in its on or off position. Is it selected or not? And really, one powerful thing about the toggle buttons is we can create multiple toggle buttons. Suppose we made 4 toggle buttons. Let's say it was left, right, up, and down here. Then we can create a toggle group, and we can set these buttons to be a member of this toggle group. So notice on each of the individual buttons, I can then set the toggle group and then pass it a reference to this toggle group. And the toggle group is going to bind all these buttons together so they can be set, so that if one's set, the others are unset. So let's take a look at what that would look like in terms of an application. So the complete application would look like this. I should also highlight these imports here. So let me do that. There we go. So here I'm going to import my toggle button and my toggle group, create my 4 toggle buttons. Then I'll create a toggle group that will allow these buttons to become dependent on one another. So this is a toggle group that groups these buttons. And then on the buttons themselves, I'll set toggle group and then pass it a reference to the group. Then what I'm going to do is I'm going to actually display the actual buttons. That's the thing that gets rendered. That's the thing that gets added to my view. And so this is what this actually looks like in practice. You've probably seen this before in a lot of forms where you have a number of different toggle buttons that are bound together. And when you select one, it unselects whatever the previous one that was toggled was. So only one can be selected at any one time. And then you can check if one is selected or not. I think, let me double check that. There's so many different options with this. Oh, it takes so long. Because I don't remember if I can toggle multiple ons with a toggle button or, let's see here. Well, we have a toggle button. Let's go to our example. And again, with any one of these, if you want to experiment, this code will be provided to you. Let's run this example code, and then we can just see the behavior. Show contents, no import. Okay, and let's run that. Now, okay, just waiting for my system to load. It's under duress. Yeah, here, let's see. We can toggle on and off, but we don't have a toggle group on this one. But this shows you how you can be able to toggle it on and off a state. I think actually you can, on a toggle button, you can actually toggle them independently of one another, and then you could check the selected status of them. All these like minute differences between the form elements or control elements. Okay, let's talk about radio buttons. So radio button can be selected or not selected. Let's just jump to what a radio button looks like. This is what a radio button looks like. Usually you have a interactable dot here that you can click or unclick. And so typically with the radio button, when you engage it, it unengages everything else. So I think this is the thing I was thinking of previously, is the radio buttons. And again, the way a radio button would look like is we would import that from the control package. We'd create a new radio button with whatever the element is, and then we can just add that into our layout. And then we can also check to see if it's selected or not. And then we can add a toggle group with the radio buttons. And so here it's going to look very much like the toggle buttons, but the toggle buttons I think are independent of one another, whereas the radio buttons, when you select one, it untoggles the other. So here we would have our radio button, we'd have our toggle group, we'd create our toggle group here, we'd register each of our radio buttons with that toggle group, and then we could draw those onto the display, and that's going to give us something like this, where we can click left or right or up or down. We select one, then it undoes the others. And then we have checkboxes. Checkboxes are kind of like radio buttons, but you can have multiple selected at one time. So here, the concrete classes checkbox. The code would look like this. You can import checkbox from control. And then when you're setting up your graphic user interface, you can just create a new checkbox. And then you can add that into your layout component. It's going to look like that, right? So usually checkboxes are rendered in squares that allow you to kind of check or X them out. Whereas the radio buttons are always dots. So that's how you distinguish usually between a checkbox and a set of radio buttons. You can also always check to see if a toggle button, a radio button, or a checkbox is selected, right? So that you can do something in response to it. You could also, so a checkbox can have a indeterminate state. So it can either be selected, it can be not selected, or it hasn't been interacted with, which means it hasn't been selected or really not selected. So you can allow it to have like an indeterminate state. And then if you want to read the indeterminate state, you can just, there's a method is indeterminate. They have choice boxes as well, which enables the user to choose an option from a predefined list of choices. And again, the concrete class for that's going to be ChoiceBox. So you can just, create one using its constructor. So an example of how we might add choices to a choice box is suppose we create this choice box here, choice box. Then we can add an item. And then we can do a dot add on this method call. So we do a method chaining, right? So we use the dot operator to call the get items from the chain, the choice box, and that'll allow us to then add something to that list of items. So since that's a collection, there's an add method, and then I can go ahead and add a string in there that could be my choice 1, my choice 2, my choice 3, whatever. So an example of this in code, I would import my choice box. I'd create a choice box. I would get the choices, the list, the collection of choices, and add whatever choices I want. So here I'll do 3 adds to that collection, choice 1, choice 2, and choice 3. Then I would pass a reference to my choice box to my layout component so I can then display it. And so that's just an example of what a choice box would look like, where here I can go ahead, pull down, and then I'd have all these choices. And I can select one of the choices, which will then be selected inside the choice box itself. So the choice box isn't a button, right? The other thing that we saw that looked similar to this was I select something, and I also have the event listener that automatically engages the handler. Here, this gives me a closed set of options that I select, and then I can bind some other button or some other thing that looks to see whether this is selected or not. So again, there's these really minute behavioral differences between all these different controls. And again, as you start playing around with them, and so I'd advocate that you pull like the code that I share, and you run all of these examples just to get an understanding of the small differences. But these should all be very consistent and similar to other form controls that you've seen before, either in web applications, in mobile applications, or in like game interfaces. Then we can read the selected value from a choice box so that we can do something inside of our application. That's typically why we include these. And then we can also listen for listening for selection. So when something is selected on there. So notice here, these are our, we have a list of choices. Since ChoiceBox is a control, we can set an on action event listener to it if we wanted to. If we do, we can, this is a Lambda expression where, so when the user interacts with it, we can check to see what the selected index is, if there is one, and then do something in response to that. So we can listen to the choice box itself and handle an action that is triggered on it. Okay, we have and any control we can set a action listener to. Like that's one of the big things, hence the term control on all these subclasses. We also have a combo box. The combo box control enables users to choose an option from a predefined list of choices. So let's take a look at that. Combo box is the concrete class. We can add choices to a combo box. It looks very similar to what we just saw before with the choice box. And here, this is our combo box. But now we can even make the combo box in a way where we can allow it to be editable. So you can set editable to be true. You can also read the selected value from your combo box. And then you can also set action, an action listener on your combo box using the set on action method. So very similar to a choice box. Okay, so the list view control enables users to choose one or more options from a predefined list of options. Here, it's going to aesthetically be a little different than both ChoiceBox and ComboBox. We can create a new list view using its concrete class. We add items into it the same way we do with ComboBox and ChoiceBox, but it's going to render a little bit that way. The coding for it looks almost exactly the same, but we're using list view as opposed to ComboBox or ChoiceBox. But here, this is going to be the aesthetic where we can just go ahead and select from a list view of our various choices. You can read selected values in a very similar way as ChoiceBox or ComboBox. This is an example of a full application using the list view. And then we can, now one thing about list view is we can allow multiple items to be selected from it. And so if you want to see how to do that, we have the ability to set up an observable list, right, to get all of the selections, all the indices that have been selected. So that is one nice thing about list view. And so in order to do that, we would go ahead and import this observable list. We'd import list view and also our selection mode. We create a list view, then on our selection model, we would set the selection mode to be multiple, so we can select multiple things. Then inside of our collection, inside of our list view, we would add multiple things in there. Then when we'll create a button that actually does something, so we can select multiple things in the list view, and then our button will actually handle the event of looking at what's selected and doing something in response to this button click. So I'm going to set an on action Lambda expression, this callback function on the button that will use observable lists to get the selected indices. So from list view, it's going to get the selection model to get all the selected indices. And so that's going to return back a observable list. And then we can go through that observable list, each object in there, and just print it out. So just an example how we can go ahead and do that, get multiple things. Okay, some other common inputs that are worth knowing, some controls that are worth knowing, something called a DatePicker. So here a DatePicker, we would create one using the concrete class DatePicker. We can import it from control. We can instantiate it, just add it right into our layout component, and this is what it would look like. And so it allows a end user to navigate something that looks like a calendar, or to input a date directly here, and then it'll navigate the calendar to be able to select a valid date that you can then read from this control into your application. Recall, all of these controls are designed to be able to get input from an end user that you then feed into your application. And so all these different behavioral differences is so that you can control how you're presenting the data and how you're feeding the data from the user into your code base in a way that is reliable and redundant and robust, and you limit the amount of options for them to kind of break your software. And then, so if we wanted to get the value back from the date picker, we can just do get value, and it's going to return back an instance of local date. So again, what a full application might look like would be this. We can import from the control package a date picker. We create a new instance of date picker. Then maybe we create a button. We set an on action event on the button. I'm going to use the Lambda expression. So the action, I will go ahead and look at date picker, get its value, save that as a local date. And then I do whatever I want with that, right? Inside my app, I can invoke some method in my function that then uses that date to do something. And then maybe even update my view. And then I'll also go ahead and render that date picker into my, I'll add that into my layout component. Besides date picker, I also have a color picker input, which allows us to select a color, and it could represent that color in the hexadecimal form. And then even a custom color that allow you to go ahead and select. And so we want to use that. we would import ColorPicker from our control, and then that's going to return back a color object. So we'd also have to go ahead and import color, the color class, from the paint package, from the scene package. And so if we want to instantiate that, we could just do new color picker and then save that. And then we can get the value from our color picker. And then we can, if we want to add that control, we can just add it into our layout element. Yeah, that's what the class looks like. That's how we can get the chosen color. Okay, text fields. We also have the ability for a text field. This is a field that enables users to enter text that we can then get the value from in our application. So to create a new text field, we just go ahead and use this concrete constructor. And so this is what source code would look like for it. Here, we would import our text field. Let me highlight that there. And then here, we would create a new instance of text fields here. I want to see that. And then here we would add that text field into our layout component. And that's all it takes to add a text field into our graphic user interface. And so what that's going to look like would be something like this, a field where you can enter text into. And so full application might look something like this. We import our text field. We, do all of the other stuff we've learned how to do. But to add this text field into the GUI, we'd create an instance of it. Maybe we create a button that says click to get text. And then we create a on action. We set a callback function on the buttons, and we all set an on the action on this button. We'll pass that action into this code block. And what we'll do is we'll access the text, get text from the text field, and just port that to the console. To illustrate, we can get, and this text would be supplied by the user, right? That's not something that's part of our code. The user had typed something in, and when they hit the button, we can then display that in the console. We're grabbing the value of the text from the text field when the user clicks the button to go ahead and read it. So again, we can use multiple controls in sequence to be able to feed data into our application. We can set initial values to our text field. So set text, initial value. So we can always call the set text on there. We also have a password field, which is like a text field, but it doesn't show you the characters being typed in there. So it just shows circles. But for all other intents and purposes, it's pretty much the same thing. But if you want that protection where you don't render what's being typed into a field, use password field if it's supposed to be secret. And again, it works the same way, right? You just import password field instead of text field from the control package. And it's going to look very similar. Okay, another type of input that's worth mentioning is a slider input. This provides a user a way to select between an interval of values and from a min to max value. So it allows you to slide all the way to the min from the left-hand side to the max on the right-hand side, or any number of values in between. Usually these are used for like volume, right? Or sometimes starting at the beginning of a video, going all the way to the end of a video. So if we want to use these, we would go ahead and import the slider from the control package. We can create the slider. So what we can do here is there's a couple different parameters for the slider, right? We have to define what the beginning and end values are and where its default value should be at, the initial value. So the first parameter here is going to be what is the minimal value of my slider. The second value is going to be what is the maximum value of my slider. And then the third value is where do I start my slider at? And at any time I can get the value of my slider so I can feed that into my application however I need to. Like again, the point of all these controls is to feed data into our applications. We need to be able to get the values at any time. We can also define things like setting major tick units inside of there. So we can also do the number of tick counts. So let's see what this looks like when we do that. And we can also set it to snap to the tick. So instead of having continuous movement on the slider, if we set snap to text, then you have a discrete set of values that the user can select. So that would look something like this, where I would have my tick, I can set to show my tick marks, and then I could have it set where it discretely snaps to each of those tick marks if I wanted to. And then I can even set show tick labels so I can actually see the values of those tick labels. So lots of controls to be able to display both setting the value with the slider and showing what the value is set to. We also have a text area. So a text area is like a text field, but it's a larger area. So if you want to get multiple lines of text from the user, you should use a text area control as opposed to a text field control. And so this is just called text area concrete class. So it looks exactly like a text field, but it's called text area. And so this is what this would look like, right? It would be a larger space that you can type in multiple lines to grab from the end user, as opposed to a text field, which is like a singular line. And then we can get the text the same way we can from a text field. All very similar, just minute differences. We can set up action event listeners in the same way on a text area. So again, so what this code is doing here is we're going to create a text area. We're going to set up a button. We're going to set a minimum width of our button. Yep. We're going to set an action event on our button where on a get action on a press, we'll get the text of the text area and we'll override it with clicked. Yep. And then we can add additional things inside of here. Some additional controls allow us to start nesting things together. Like we can group buttons together to build a toolbar, for instance. So say, for instance, I create a new toolbar. Then I can create a new button, and in my toolbar, I can get the items that are my toolbar, which are going to be other nodes, and I can add to it my button element, for instance. So let's take a quick look at that. Say I create a toolbar here, and then I create multitudes of buttons. So I create this button 1, and then I'm going to add that button. I'm going to pass that button in to my toolbar. I'm going to get back the collection of children, the collection of nodes that this toolbar contains. I'm going to call the add method on that collection and pass that button. Then I'm going to do that with another button here. So I'll make a second button, add that. Then I'll add the toolbar itself to my layout. And what that's going to do is create a toolbar that looks like this. So notice that's going to create like a toolbar above the rest of my scene, where I can then select those buttons. And I can also go ahead and set the orientation for my toolbar. So it's vertical as opposed to horizontal. The default is horizontal. I can even separate the items in my toolbar. So notice here, they put a separator between each one. So I can create a new separator that I add in between that collection of values in my toolbar. I can also have a tooltip. So a tooltip can go ahead and display a small pop-up that explains text when the user hovers over it. So here, this is an example of creating a new tooltip where we pass in a string, creates a new file. Here, I can create a new button, and I can set the tooltip. So on my button, I set that button to be part of the tooltip. So here, notice what's going to happen here is, so I create a tooltip that has a string. It's the explanation, creates a new file. Then I'm going to add that tooltip to a control object in my graphic user interface using the set tooltip method. So now if the user scrolls or hovers over the button, it will then render that tooltip message with that string, creates new file. So simple, super simple to use, and it's a good way to convey information to your end user. And again, you can decide where you're going to align the text on the tooltip. So you have rendering options on that. You can also set graphics into the tooltip. So if you want to have some kind of logo or icon, you can do that. And then you have your progress bar. So you can go ahead and create a control capable of displaying the progress of some task. So here you would import progress bar from your control package. You can create your new progress bar, and then you have to say what it's currently at. You can set the progress at any time. So 0 to 1 is going to be your min and max values. And so you can use any decimal, a fractional value between 0 to 1 to illustrate the % of completion. So this would render something that is halfway complete. And so let's see if we can't. And the last couple of things I just want to show you is we have a file chooser. So if you create a file chooser, it produces a dialog that allows a user to peruse their file system and select a file that will then be able to get referenced inside of your application. So if you want to use a file chooser, you can just use the concrete classes file chooser, just new file chooser. And then you can check on the file chooser instance, you could show the open dialog in stage to get the selected file. So this will allow you to show the file choosing dialog. And then this will open the dialog so that they can navigate. And then when it returns, it'll return when they hit that OK or that submit button. And then it's going to return back a file object that is the selected file that they chose from that dialog box. So again, this is just what that would look like in action. So here we would have a file chooser, which is actually part of the stage package because it produces a dialog, but it's very much like a control that's worth knowing about if you need to get a file from your end user, and it's going to return back. So here we can create a file chooser, and then we can, on this button, create a action listener that will tell that file chooser to show that open dialog and then get back that file. And then we could use that file in our logic however we might need. And then the other thing is a directory chooser. So directory chooser works very much like file chooser does, but instead of allowing the user to choose a singular file, it allows them to choose a directory instead. But ultimately, it looks very similar. Concrete class for us to use. We have that show dialog option where it then returns back a file, but this file represents a directory and not a file. And so this is just code that looks very congruent with what we saw before in terms of being able to go ahead and say, for instance, have the user set a directory that they want all their output files to go to. Now, in this instance, if this directory chooser is allowing the end user to choose a directory to send your application's output data into, you might want to have a default directory selected. And so maybe, for instance, this is the default directory, the initial directory that the directory chooser would choose from. And then maybe the user can override that by choosing another directory. And so if you've gone through a set of inputs that give you the option to have a default directory or to go ahead and select a custom directory, this is the kind of control that was. Excellent. Oh my God, we went through so many different controls, but I think for the most part, this is every kind of control element that is worth just knowing about in JavaFX. And so you have some source code references here. You have actual real code in the demo project that I'll share with you. So does anyone have any questions about the variety of like control subclasses that you have available? And these were really just the ones that directly the user would interact with. Understand there's another set of control subclasses that are designed to be container classes. Excellent. So if there's no questions, I'll go ahead and I'll end today's lecture then. And then we'll have one more lecture tomorrow where I'll talk about the layout components, and I'll finish up with what has to be mentioned with JavaFX. But I feel I'm in a really good place here. We've learned how to render elements. We've learned how to set up our controls. We've learned how to interface our elements, our JavaFX components with our Java objects. And really, that's what all of that is what it takes to build a graphic user interface. Really, though, you're only going to know this stuff by practicing it, by using it. So even though we don't really have time inside of the classroom for you to build a graphic user interface, I would implore you to try to take these slides and play around with the project, the source code that I have as part of these slides, and see if you can't go ahead and make some of your own projects to get comfortable with this concept. Because if you know how to build your own graphic user interface applications, it's going to make you much more marketable when you start looking for internships, or if you start looking for job positions. Knowing how to build applications as they really appear It's going to give you a leg up versus, anyone who just knows how to build command-driven applications. But as you can tell, there's a lot that goes into graphic user interfaces. There's a complexity there. Okay, well, if there's no follow-up questions, I will go ahead and end today's lecture then. And I'll post this as soon as it becomes available.